All right, welcome back. We're at 12.5. Excuse me. So for 12.5, we're going to start out with those two files that I provided in the overview for Module 12. The two files that were next to Exercise 12.4 that was problematic. Now, we're not going to have problems with this one. So copy in that graph.py and the algorithms.py starter file for 12.5, which is the solution file that I gave you for 12.4. So now that we've got those two files, we can proceed with this one. So let's jump into algorithms, and let's start out with, we'll go to the very top of algorithms. First thing that we've got to do is to add in another linkage here. We need to import linked Q, and we're going to get linked Q from that import. Okay, so there's our first hurdle. We're not using the stack, we're using a queue. Now, with this, we're dealing with directionality because we're doing breadth first. Recall we're doing breadth first. Yeah, we're doing breadth first. So let's come down to right after find least cost edge. We're down around, I think, line 131-ish. Let's define this algorithm. So we'll give it the name. It's going to receive a graph and a start label. It's going to be the same for any of these algorithms that we're going to do. Now they gave us a little bit of something we can put in as a comment what we're going to do. It's going to return a list of vertex labels in the order which that they're visited. So we're going to return some result. Enter a couple of times and come up. Result equals list. Now, let's go ahead and clear any vertex marks. First and foremost, and we'll set up our queue. That's going to be a linked queue that we're setting up. Now, we'll go ahead and for the queue that we've got, let's go ahead and we're going to add that start link, that start label, to the beginning of it. So we're going to get the vertex of the start label. So far I've got this empty list. I've got a clean graph, there's no marks on it. I've created an empty linked queue, and I've now added the start label to that queue. So there's where we're starting. Now we're going to have to do a loop to get through all this. So we'll do a while not Q is empty. Vertex equals Q dot pop. Is marked. Okay, if it's not marked, we'll mark it. And the result, I'm going to go ahead and append. And we want to get the label. Text again. Why is that doing that? Okay. So we marked it, we added it to our results for neighbor. It's in G dot neighboring vertices. Vertex dot get label. Find out what's around me. And if neighbor is not marked, add them to our queue. Come right back up. So we're going to keep going down through until queue's empty, and we're just literally working our way right down each of those branches on the tree, if you will. I like to visually think about turning these trees, and it's not, well, I shouldn't call it a tree because we're dealing with a vertex, but conceptually it's the same thing like navigating down through a tree. Okay, so we're doing the same thing, just running down all the vertexes. Okay, now let's go see. We should be good on this because that's the extent of the algorithm that we've got to deal with. Run it. Topo.txt. And we got to run 7. Oh, I got a typo somewhere. There's vertex. So I've messed up with that vertex and vertex somewhere in algorithms. And there it is. All right. Go back. I'll go to view. 2. So it ran, and it was just that little typo that I had. Instead of vertex, I had vertexed. And it auto-populated those without me picking it up. And I saw it once or twice, but I just wasn't thinking of where it was pulling it from. That's the extent of 12.5. See you 12.6. And keep these, because we're probably going to need to carry these forward.